The next building block in algebra is the concept of a variable. Now, a variable is a letter, so we'll go ahead and define this. A variable is a letter that represents, I don't know if I can fit that on there, represents, that is the word represents, that represents one or more numbers. And I'm going to use the pound sign, or as young people today would say, the hashtag, to replace the word numbers there. So typically in algebra, a variable represents a number that possibly could change. So for example, time. If you are riding a bicycle, after 1 second, you've ridden, 1 meter. After 2 seconds, you've ridden 5 meters. And that time can change, so as time goes by. So when you're dealing with it algebraically, you might use the letter T to represent time, knowing that there'll be different times that are possible. An algebraic expression, and this is important to note, so we're dealing with expressions, are simply collections of numbers, variables, and operators. Okay, so a collection of numbers, variables, and operators. And remember from our last lesson, an operator at this point is adding, subtracting, multiplying, and dividing. So that's what we have for operations. So I'm going to go through some examples of algebraic expressions and then what they mean when we look at them. And then we'll talk about what it means to evaluate an expression. So this would be an example of an algebraic expression. So we have the number 8, and then we have the variable y. And it's really important to know what that means. That means 8 times y, or 8 times, we might use the dot for multiplication. So that is implied multiplication. You're taking 8 and you're multiplying it by some unknown number y. You could also have an algebraic expression that has more than one variable, like 4r plus s. Now, typically we don't use a lot of s's in algebra because they tend to look like 5s. It's not that we never use them, but we do tend to avoid them for that reason. And this would be 4 times r plus s. Okay, so you get an idea of what an algebraic expression is. Now when we talk about evaluating an expression, okay, and I do this with my Algebra 2 students all the time because it's so important to know what the words mean, because in it, like directions in a problem, it might say evaluate the expression, and you need to know what that's asking you to do. So essentially, evaluate means plug in the numbers and then simplify. And you simplify it according to what we did in the last lesson, which is use your order of operations and carry out the operations on the numbers. You could think of it this way. You write the algebraic expression, you substitute the values that you're given for the variables, and in a math class, you're often just given the values for the variables, and then you simplify it. In a science class, which is where you end up using most of your math. So most of your math you'll use in a science class or an engineering class. The tricky part is that you have to know the math before you can do the science, which means that you end up like learning all this math with no great idea of how it's used until you need to use it. So you really do need to be patient a little bit. Let's work through a couple of examples here. So if I have the expression 4x plus 5y. And then in a math class, you would be given the values. So when x equals 3 and y equals 2. And you might be like, well, where did you get that from? Well, it came in the book. It came from the teacher. In a math class, you'll usually be told what the values of the variables are that you need to evaluate it for. And again, in a real life application, when you get to this in a science class or an engineering class, those numbers will come from somewhere else. They'll come from the context of the situation and what you're interested in. But for now, in a math class, you're really focusing on the skill and putting the skill in place so that when you see it later, you'll know what to do with it. So we make a substitution, and I do this in Algebra 2. When you substitute, you take out what is there and you replace it with something of equal value. So if you make a substitution in cooking, okay, so maybe you're going to substitute chocolate chips with butterscotch chips. You take out the chocolate chips. They have to come out of the recipe, and then you put the butterscotch chips in. My dad is diabetic, and so my mom will sometimes do a sugar substitution. She's got to take out the sugar and then put in whatever the substitute is. If you're into sports, think about a sports substitution. You would take out one pitcher in a baseball game and replace him or her with like another pitcher in the baseball game. You don't have two pitchers in the game at once. So when we're talking about substituting for the x, we're going to take out the x and then we're going to replace the x with something equal to x, which in this case is the 3. Now remember, that is multiplication. So you can't just write 4, 3. That's the number 43. When you do the substitution, you have to replace it with some symbol that indicates multiplication. And you can really pick anything you want. So you can do a time sign, like the little dot. We would avoid using an X in algebra. We avoid using the little X for times. For two reasons. The most obvious is that we don't want to confuse it with the variable x. The other reason is that when you get into much higher levels of math, there's a difference between the dot and the x. It's actually two different kinds of multiplication, and that is eons from this lesson, so don't worry about that. Now we'll replace the y, and in this problem, y is equal to 2. And so just to kind of change it up, you might use, that's horrible looking. Let me see if I can do that a little bit better. You might use the parentheses, okay, which would indicate 5 times 2, but you can't just write like 5, 2. Okay, and I've seen students do some pretty weird stuff like that, where they'll write it like a 5, 2, but then they'll try to write like the 2 up high or something. Don't make up your own notation, okay? Like you have to use an approved time sign. You can pick which one you want, but all right. 4 times 3 is 12. 5 times 2 is 10. And then 12 plus 10 is 22. And that's what it means to evaluate an algebraic expression. Let's see if there's another one. You can be asked to maybe evaluate for different like values of the same variable. So for instance, let me see. I'm looking at a book. So we might have x plus 7 and then divided by 5. Okay, and the directions might say something like this: evaluate for, or evaluate when, x equals 3 and x equals 208. If you see something like that, it's two different problems, because obviously x, like it's a variable, but it can't be more than one thing at a time. Okay, so x could be equal to 3, like if you're talking about like 3 seconds into your race, or x could be equal to 208 if you're 208 seconds into your race that you're running, but it's not going to be 3 seconds and 208 seconds at the same time. And so if you see something like that, it's actually asking you to do two different problems. So for the first one, and we might like just call this like part A, again, we take out the x and then we're going to replace the x with something of equal value, which in this case is 3, and then copy down the rest of the problem and then follow your order of operations. And we'll do like a whole lesson on order of operations soon. So 3 plus 7 is 10, and then 10 divided by 5 is 2. And then let's do the other one. So again, it's a separate problem. So we're going to take out the x and replace the x with 208. And everything else gets copied down. We want to work on that structure. 208 plus 7 is 215. And then I know that's divisible by 5 because it ends in 5. I don't actually know it off the top of my head, so I'm going to do a little scratch work. 5 goes into 21 4 times, and then 5 goes into 15 3 times. And so we get 43. Try as much as possible to work from top to bottom, okay? And write your answer at the bottom. Couple other vocabulary words. Okay, so last lesson we talked about the sum. Okay, when you and the sum means adding. If you have like two things that are added together, these are called terms. Okay, so they are added together. So those are called terms. Terms are things that are added. Now, sometimes when you'll hear this defined, it'll say added or subtracted, and that just has to do with like negative numbers coming into play. You can get away with just saying added. The other one is product, and we did this in the last lesson. Product means multiplying, okay? And when you have two things multiplied, remember that this is multiplication right there. These are called factors. So terms are things that are added. Factors are things that are multiplied. Really, really, really important. Years ago, I was teaching an Algebra 1 class, and I kept saying something along the lines of, like, you can't combine, like, you can, what was it? Like, you can multiply unlike factors, but you can't like add unlike terms or something like that. And it took me a while to realize that my students didn't actually know the difference between terms and factors. So it didn't matter how many times I said something about terms and factors. Like if my students didn't know the difference between what those two words were describing, then I wasn't helping them as a teacher. So terms are things that are added. Factors are things that are multiplied. Very, very, very important concept. All right, last thing in this lesson that I think is really worth talking about is just formulas. So one of the areas where you'll see this idea of like algebraic expressions and substitution and evaluation is in some of your basic formulas. So for example, if you have, say, the, distance equals rate times time. I'm used to like a physicsy version of that. So D stands for distance, rate, or the R might be equal to like your speed, and then T is the time that maybe you're traveling. So if you run, say, 3 meters per second, that's an S, and you run for, 60 seconds, then you can use a formula like that to figure out how far you've run. And you can actually do some operating with the M for meters and the S for seconds as well. It's called unit analysis, and you can actually treat them the same way that you would treat numbers, and it's super useful in higher level math. But for now, we'll just do 3 times 60, which is 180. And the S's actually do cancel out, and you are left with your units in meters. And so you'll see a lot of applications with your substitution and evaluation when you're dealing with a formula. You just need to be able to like look at your diagram. So if you're doing, say, like the area of a rectangle, and the area is equal to the length times width, you would need to know which number you are like pulling off of your diagram and stuff in order to plug into your formula. All right, I'm going to put a couple of practice problems on the screen so that you can test out how well you are doing on this particular concept, and then we'll go over them and we can talk about the answers. All right, here are a couple to look at. First problem, the first 4 are just evaluate, and I did try to phrase these in slightly different ways so you could get comfortable with the different ways the questions might be asked. So first question, 2x plus 1 when x is equal to 4. So it's telling you what the value of x is. 3a plus b if A equals 2 and B equals 1. So you can see when, you can see if. Number 3 uses the word for, which also works. So 24 divided by x plus 2, for x equals 2 and x equals 0. And then the fourth one, a minus 2 all divided by. Notice how I said that. I said all divided by, which indicates like the parentheses. It's a way to indicate the parentheses out loud when you're talking. Divided by 4a. And it is assumed there too that the 4a is like grouped together. So yeah, so I'll put the parentheses around there just so there's no question about how that should be grouped. And then question 5, a car traveled for 2 hours at a constant speed of 72 kilometers per hour. How far did the car travel? And that'll be just a formula. So take a moment, pause the video, try to do these out on your own, and then unpause it, and we'll talk about the answers to the problems. All right, so the first one is, remember, the directions are to evaluate. So 2x plus 1 when x is equal to 4. So we take out the x, we replace it with something of equal value, which in this case is the 4. And then we evaluate, which means we're going to simplify. So 2 times 4 is 8, and 8 plus 1 is 9. The second one has 2 variables in it. So a is equal to 2 and b is equal to 1. So we take out the a and replace it with a 2. Take out the b, replace it with a 1. 3 times 2 is 6, and 6 plus 1 is 7. And if you're checking your work, even if you can do them in your head, okay, which I'm aware that there are people watching this video that very likely can do these problems in your head, don't. Make yourself practice the writing. It's not a lot of writing. We're talking about 4 lines max with the writing to develop the habit of how to keep your work organized, because I promise you the problems get so that you can't do them in your head. And when you can't do them in your head, you need to have that nice structure and organization to your work to fall back on. Now remember, when you're given 2 values for a variable, it can't be both of those values at the same time. It's actually 2 different problems. So evaluate it if the x is equal to 2, and then evaluate it again if x is equal to 0. So for our first one, we're going to be plugging in x is equal to 2. And then remember that we do the grouping symbol first. So 2 plus 2 is 4, and then 24 divided by 4 is 6. And then the other one isn't actually separate problems. So 24, and then this time we're going to take out the x and replace it with a 0. 0 plus 2 is 2, and 24 divided by 2 is 12. And so for that one, you actually have 2 values. The next one, this one, and it reminds me of the one that I did in the previous video, where you have this left to right, order of operations says you do multiplication, division from left to right. And I believe the intent of this problem is to make sure that you do the 4a first. If you don't put the parentheses there, you would divide by 4 and then multiply, which I don't think is what they want you to do. So, all right. So here you've got 2 different a's. And if you see that, they're both equal to 4. So just so you can see what we're doing there, we're replacing both of the a's with the 4. Okay? Oh, there we go. So when you have multiple variables, that's how that works. Then we do our grouping symbols. So 4 minus 2 is 2. And then 4 times 4 is 16. Now you've got a couple options here, because I didn't give any directions about what form to leave that in. If it were me, I would write it like this, and then I would simplify the fraction. These are both even, so I know they're both divisible by 2, and so this would be 1/8. But you could grab your calculator and change it to a decimal. If there's no directions given, then you can leave it however you want. And then the last one was the car. So what I'm going to do is I'm actually going to use a strategy that I learned when I was in high school, which is to write down the givens, plug it in, and then evaluate. So I'm actually going to write down a car traveled for 2 hours. So I'm going to write down T equals 2 hours. Okay, that's called like writing my given. It was in the problem that the car traveled for 2 hours. So I'm going to write it down. At a constant speed of 72 kilometers per hour. So I'm actually going to write that down. Like so. So the rate or the speed. Now I'm going to write down the formula that I used to solve the problem. And now I will take my two values and I will plug them in to the formula and evaluate. So the rate was 72. The time is 2. And so that would be 144. And really, like the way the units work, you're doing hours times kilometers per hour. So you're going to be in kilometers. Like literally how that works is you're doing like kilometers per hour times hours. And if you divide and you multiply, like they end up canceling out and they leave you with the kilometers. We haven't really done like inverse operations and canceling stuff out. So if that was confusing, just kind of ignore it for the time being and we will come back to it later. So that wraps up our second lesson in our coverage of Algebra 1.